I get a lot of questions about the 3 different question types that we can use regression analysis to help us answer. And so we're going to just talk through an example and hopefully motivate the 3 different question types and why we want to think in terms of those questions and how it shapes the way we think about analysis. So on the board here, I have a little model set up. So the outcome that we're trying to predict is the maximum salary that a person earns over the course of their career. So whatever their top salary is before they stop working altogether. So that's what I mean by career maximum salary. And the variables we're going to use to predict that are gender, education, years of work experience, and the job type. So with this same model, that's going to be estimated the same exact way in R, there are 3 different kinds of questions that I want to demonstrate as being questions that we could answer using the results from this model. Now, when we answer those questions, we would actually be looking for slightly different things, which is part of what we're going to talk about here. So the first question type is a single cause model. And in a single cause model, the question is something like, and I'm just going to use the example we have here on the board, something like, does the gender of a worker impact their career maximum salary? So here I'm looking at the relationship specifically between gender and career maximum salary. So I'm looking for a wage gap. I'm looking to see if maybe men or women have a higher career maximum salary as a result of their gender. Now, in order to do a good job of estimating this model, I would need control variables. So what I'm going to be looking for those control variables is going to be things that I expect to correlate both with my X variable of interest and with my Y variable of interest. So I might expect that there's some correlation between education and both gender and maximum salary. Same for years of work experience. And it's also possible that men and women are attracted to different job types or selected for different job types. So I'm including education, years of work experience, and job type because they're good control variables for the question I'm actually asking, which is, does gender have an impact on maximum career salary? So if I move on to the second question type, the second question type is a greatest cause question type. So in this case, so I'm just gonna change this out. So now we're talking about greatest cause. And now I'm going to ask a different kind of question. I want to know in this case, which has a bigger impact on salary? Is it a person's education or is it their years of work experience? And I want to know which of those 2 things matters most. So instead of looking for a correlation specifically between each of these things and the outcome and then using everything else as controls, part of the reason that I'm including both of these variables here is because I want to compare between them. I want to see which of these 2 has the biggest impact on career maximum salary. So I'm going to be looking for slightly different statistics. I'm going to want to measure these things in a slightly different way and include them in the model in a way that makes them nice and comparable. And I'm going to be comparing the size of impact rather than just answering a yes or no question about whether there even is an impact on career maximum salary. So that's the second question type. Both question type 1, where we're looking at a single cause, and question type 2, where we're looking at greatest cause, both of those have very causal logic. In other words, I'm trying to build a causal argument, and that's why I'm looking for correlations. Correlation is one of the 4 things that I'm going to need to establish in order to demonstrate that there's a causal relationship. The third kind of model is a predictive model. So this one's predictive. And with this kind of model, we're doing something slightly different. I'm going to include all these same variables, but I don't actually have a specific question about whether any of these x's cause y. And in fact, really, I am only including those variables that I think do have a likely impact on y, because the goal here is very different from the prior two models. The goal in this case is to be able to make accurate predictions about new cases, okay? So I'm going to take a bunch of data that I already have and that already exists, and I'm going to estimate a model where I gather information about gender, education, years of work experience, job type, and career maximum salary. I'm going to gather all this information for lots of observations, and I'm going to build a model. And I'm going to use that using regression analysis. And I'm going to hope that that model is really accurate. And the reason that I want that model to be really accurate is because then if I have a new case come in, I want to be able to predict with a reasonable amount of accuracy what their outcome is going to be. In other words, if I have a new person come into my office and say, what would you predict my career maximum salary to be? I want to have a model in place where I can say, okay, I have a mathematical formula that I can use to predict your career maximum salary, and I want that to be as accurate as possible. So you person who just came into my office, I'm going to ask you what your gender is. I'm going to ask you what your education level is, what your years of work experience will be for this career maximum salary question, right? What will your years of work experience have been? What will your education have been? And what kind of job are we talking about? And so I would take all of those things, those new numbers that weren't part of my original data set, and I'm going to plug them into the model that I've created, and I'm going to come up with a prediction for the career maximum salary. It's a really different way to use the model, but I can use the same output, the same variables, the same information to do that. But I might think about a predictive model, and I might choose my variables for a predictive model slightly differently than I do for a cause model. So that's the third kind, and this is for sure the one that I get the most questions about, in part because it's often harder to see predictive models because we just don't think of them in the same way that we do the causal models. But that hopefully is a good illustration of how we can use the same exact regression model, the same y variable, the same x and z variables, and how they might sort of dance around in terms of whether they're x variables or z variables, whether they're causes or whether they're controls, or whether they're just included to help us create an accurate prediction. So hopefully that helps illustrate the concept of the three different question types, and especially a predictive model.